Let's do 5-4. So it says find the integral of this from this to 1 of this. Well, to do this, we're going to split this up. And t to the 2 in the denominator is t to the negative 2 in the numerator. We're going to take it times all this. So we're going to have the integral from 8/27 to 1 of 10 t to the, if we're adding a 2 to 4/3, 1 1/3 is going to be 3 1/3 or 10/3 minus, oh, wait a minute, minus 2. So minus 6/3 from 4/3 is minus 2/3, excuse me, minus 2/3. And minus 2 plus 1/3 is minus 5/3. 8t to the minus 5/3 dt. So I just bring this up as t to the minus 2 and distributed it. And this becomes 10 and t to the minus 2/3, add 1 to it, becomes t to the plus 1/3. And divide by 3, which is 1/3, which means multiply by 3. So it's 30t to the 1/3 minus 8. And if we raise this by 1, it becomes minus 2/3. And divided by negative 2/3, so the negative makes that positive, and multiply by 3/2, so that would turn that to a 4. And I'm evaluating, so I don't go plus c, from 8/27 to 1. So we have 30, 1 to the 1/3. Cube root of 1 is 1. Plus 12, 1 to the cube root of 1 is 1, to the squared is 1, and negative in the denominator is still 1, so it would be 12 times 1. That's putting in the 1, minus, now we put in the 8/27. The cube root of 8/27 is 2/3 times 30. So that's really just 20 plus 12. And this says cube root of that, which is 2/3 squared, which is 4/9, flipped over 9/4. So we have 20 plus, goes in there 3 times, 27 for this part. In this part we have 30 plus 12, 42. So we have 42 minus 47, which is negative 5. Oop, I'm off the page again. All right. The integral of secant tangent is just secant. Evaluated from 0 to pi over 6. So that's just 1 over cosine of theta, evaluated from 0 to pi over 6. So we get 1 over cosine of pi over 6 minus 1 over cosine of 0. 0. So this is pi over 6. The cosine is square root of 3 over 2. So this is 2 over the square root of 3. minus cosine of 0 is 1, so minus 1. Now you could rationalize and stuff, but that's good enough. 45. We've got the absolute value of the cubic, which looks like this, and so the absolute value would look like this. This gets flipped up, so we just got to do the opposite from minus 2 to 0. So this would be the integral from minus 2 to 0 of negative x cubed dx plus the integral from 0 to 3 of x cubed dx. So we get negative x to the fourth over 4 evaluated from minus 2 to 0 plus x to the fourth over 4 evaluated from 0 to 3. That becomes 0 over 4 is 0, so we got minus 0. Put in minus 2, we get 16 divided by 4 is 4. 4 minus a minus, which should be plus 4. Plus, put in the 3 to the fourth is 81 over 4 minus 0. So we've got, what, 20 and 1/4 plus 4, 24 and 1/4. And this one, the integral of this is the integral from b to b squared of 1 over x dx, which is ln of the absolute value of x, evaluated from b to absolute value of x between b to b squared. So we'd have ln of b squared. I can drop the absolute value because b squared is always positive, minus ln of absolute value b. And when you subtract, you divide, so this could be ln of b squared over b, absolute value, which is ln of b.